Right. Well, my web Twitch is not working right now. It's not actually showing my webcam, either the built-in one, or the USB webcam. So I guess you're just gonna have to. If you're watching this, I'm sorry, you can't see me, but that's okay. I can't see you either. So anyway, I guess I'll jump in here without seeing me. I'll just say that my name is Owen Bickford. I'm a software developer at SmartLogic, where it's an agency and based out of Baltimore, but everyone works remotely these days. And actually, what I'm here to talk about is an app that I've been working on my own time called LiveShowy. So I kind of debuted the first version of this at Big Elixir just about a month ago in New Orleans, and that was a lot of fun. In a nutshell, it's basically an app where this is kind of the new version of it, but the first version of the app was designed so that people inside of the auditorium could connect to Wi-Fi, which would and then connect to the app running on my laptop, and then they would press and play keyboard notes on their iPhone or on their laptop, and that would eventually produce sound through the PA. It was actually in real time, like 0 milliseconds real time, or something really close to that anyway. So that's what I was working on, and it went really well. A couple of hiccups, but it did work in the end. And so I'm working on a new version that I intend to deploy to the internet. And the first thing you typically have to do sometimes whenever you're building an app is figure out authentication. Now, I could build all the features that I built in the original LiveShowy for the web version, but it kind of starts to break down without an actual user pretty quickly. So I decided I wanted to go ahead and tackle this user and authentication scheme for my app before I work on much else. I've done a couple of things here. So I've added Tailwind. I've got a couple of components I've built. So it's not a bare bones Phoenix app. But what I'm starting with now, I've actually worked on this for a couple of weeks now. I've been building password-free registration and login. So I want to avoid passwords completely if I can. And it seems like as of 2022, it's entirely possible to do this. There's a newish API called WebAuthn, short for web authentication. And so it allows you to use the biometric IDs. So if you have an iPhone or iPad or MacBook, you can use Touch ID, Face ID on some devices, and then Windows users can use, I think it's called Windows Hello. And in addition to that, you can use physical security keys like a YubiKey. I have one of those. It's really great. And I can even take it and use it with my phone through NFC, and that's really amazing. And the beautiful thing with that is with LiveShowy, I don't necessarily need to ever create or store passwords. All I need really is just an email address so I can provide support in the future. I need usernames so that users can communicate with each other without revealing their email addresses. And then we'll need some kind of credential so that we know that this is the correct person to access an account. So that's all going to happen with WebAuthn. And if you're curious about what that is, this is a great resource just to get started. So WebAuthn.io. It's kind of got a prototype or like a way to kind of toy around and kind of tinker with registration and login, so you can kind of see how it works. And to my understanding, this site does not save any of this data, but you have to kind of take them at their word on that. But anyway, they're not really asking for much data anyway, as far as I can tell. Well, as far as I've looked into it. So all of this page asks is to provide an email address, and then you have a few options because this is just kind of a demo for using web authentication. So we're going to skip over attestation type. That's not something that's really important to me or my app yet anyway. There's authenticator type, and I'll pause a moment to explain what's happening here. So cross-platform authenticator type would be like the YubiKey or like a thing that didn't come with your device. So like a YubiKey, or there's a Google Titan key. I think there's maybe some others out in the world now. cross-platform keys would be things that are not provided by whoever manufactured your device. The other option would be platform. So platform or TPM is like if you get a MacBook, newer MacBooks have Touch ID. iPhones typically have Face ID or Touch ID these days. And Android devices also have some form of authenticator built in. So if I don't necessarily want to pick and choose that for the user, if I want to allow users to use either one, I can leave this unspecified. There's not really much to go over here in advanced settings. It's not really important for what I'm doing. So we'll go ahead and register. And the first thing that happens is it asks which type of device you want to use to register. I don't have an Android phone, so for this case, I'm going to use a YubiKey. I have plugged into my computer. It's flashing green right now. So I can select USB security key. I'll do that. Now it shows me here that I've registered and I can log in. So what it's doing now is behind the scenes, they've got like a security key that was generated from my YubiKey, and this probably all sounds confusing, but there's kind of like just imagine there's some random text that is stored in the site, and they're kind of going to ask me to confirm that now before I can actually log in. And that's what I do. So I'm logged in now, and you can see that I've done this a few times. So I was actually able to log in with a key a different key that I'd used on a different attempt. But those are all here. These are actually going to disappear after 24 hours. There's a lot more information here. There are SDKs for the most popular languages. Now, Elixir is not on this list. So when I decided to go ahead and tackle this or to go down this route, at first I tried to implement things without any external libraries. So I went to this WebAuthn guide. It's webauthn.guide. It has a really nice guide here for interacting with the APIs, and there's some example code, which is exactly what I like to see. So without going through each and every paragraph and bit of code here, this is kind of the best place to get started and kind of reading up on WebAuthn, and this will show you at least the JavaScript side of interacting and kind of getting a challenge, getting a credential, and then it shows you a little bit of how to manage those things. And if you need more information, there's a more in-depth documentation on the MDN docs for the web authentication API. And you can jump to specific function calls and things like that here. There's an illustration of registration if these types of graphs make more sense to you. Also, I'll point out here that I've gotten some great help from the community. I started on this a couple of weeks ago, and I've kind of changed course as I decided to go ahead and use a library or two to get this working. Got some great help from the community, and a couple of the maintainers even jumped in and helped out here. So that's been really great. If you want to find this thread, go to elixirforum.com and search for implementing WebAuthn via LiveView. So speaking real quickly about the library that I'm using, it's called Wax. If you go to HexPM or HexDocsPM, make sure you search for Wax _ because there was a name issue. Anyway, so that's what I'm using here, and I'm going to go ahead and move this over so we can take a quick look at some code. So if I remember correctly, I've removed this user from the database, so I can go ahead and register. I'm using a fake email address and username. This is pre-populated just so I don't have to type these things every time I open the page while I'm developing. So I'm going to hit sign up, and it's going to do a couple of things. It's going to tell the browser that I need a credential. I'm sorry, it's going to tell the server that I need a challenge. The server is going to create a challenge. It's going to send some challenge data to the browser. The browser is going to take that challenge data. It's going to use the credentials and web authentication API to create a public key and an ID that can be sent back to the server. And those things can be stored securely. And the nice thing here is that the public key even if someone else gets that public key, it's kind of like having half or like a part of a physical key. Like if someone, like if you sawed your house key in half so that you had to have both pieces, it wouldn't really matter if someone only had one piece because they wouldn't necessarily be able to get in. Of course, lock picking and so on. It's not exactly a one-to-one metaphor, but that's the idea of public and private keys. Your device will have a private key that is never sent to the server, and that's part of the thing that has to be combined with the public key before the server and the client will agree that you are the person you say you are. So that's the beauty of WebAuthn and cryptography, some cryptography stuff in general. So anyway, I'm going to hit sign up here. You're going to see it's going to ask for this USB key, or I can use my device. I'm going to do that this time. I'm going to use my Touch ID. By the way, you could use your operating system password, or maybe if it's a mobile device, you could use a PIN number. So that's another option if you don't like to use Touch ID for some reason, or you don't have access to these things. Your operating system might just ask for a password from the operating system or a PIN number. And that kind of serves the same purpose. All right, so you can see here we've successfully registered a user. And if I look over at the database, before we look at the code, I'm going to refresh. I've got a user here. I prefer to use unique ID, so I have a UUID. That's a universally unique identifier. And on this table, this is my users table. I hope the text isn't too small. But I've got my email address, username. We're going to ignore confirmed at for now, and then timestamp columns. The next thing to look at is user keys. So a user key in the database has its own ID. And then there's a key ID that was actually created by the client, so on the browser. And then the public key, which was also created in the browser. So these are stored as binary. And they're very tiny columns because there's only 77 bytes in this column for this row and then 134 bytes. So minimal footprint on the database. And then finally, this is linked back to the user that created the key. And of course, if I delete that user, the user key will be deleted as well. And then another thing I did during registration is I went ahead and put a user token into the session on the browser so that the site will consider that person logged in. Now, I'm not redirecting the user to another page yet. That's the next thing I'll be working on. But in the database, this is what the token looks like. It has its own ID. So you can kind of get, there's a pattern here. Every resource in the database is going to have a unique UUID. This token is associated with the user as well. And then it has a token which is also stored as binary. There are different types of tokens that can live in this table. There are confirm tokens for confirming email addresses. There are password reset tokens, which were generated by default whenever I set up the basic authentication. I will be removing that. Those reset tokens will never be created or used. But in a traditional app with a username and password, you might use something like a reset token so that an email sent to a user for a password reset is only good for a certain amount of time with a certain key that was passed back and that kind of thing. So, and then you might notice that there's no updated at column here because this particular table, these rows are never going to be updated. They're only created and they basically expire, so they will be deleted eventually. All right, so that's the database side. And you can see here, I've got my IEX shell open. So you'll see that this is where those things were being inserted into the database. There's the public key being added. Here's user tokens being added. And then here's the users table where it added the username and email. Right, so that is the database side of things. I'm going to go ahead and hide the shell. I'll do a quick walkthrough before we wrap things up. Let's see, is anyone actually watching in real time? I see users. I don't know if these are bots or real. I guess if you're real, you could send a message and I might even see it. But anyway, so I've got my LiveView here. So this is the registration LiveView. I really need to rename this to sign up just to be consistent with the interface. But at any rate, it's a registration LiveView. If you're new to LiveView, you can think of this as kind of like a controller, a template, and a view all rolled into one thing. And instead of sending multiple HTTP requests back and forth from the browser to the server, it maintains a solid, a consistent, a persistent WebSocket where it sends information back and forth. So you can send much lighter messages back and forth to the server. And it's really, really efficient and really great for real-time stuff that I want to do later on with this app. So we'll do a quick tour here of the functions that I've created. We'll skip over some things. This function or this callback, in LiveView, you have some callbacks that are defined or required that you have to implement these things in order for your LiveView to work correctly. So the first one is called mount. This one is required. So I've got a couple of kind of versions of the mount callback on my app here. This first one doesn't quite work yet. I've got some more things that need to be done before that will do what I want it to do. But this is the one that's actually doing the work right now. So whenever this page mounts, and if you're coming from React, just think of like all the JavaScript you would normally write. It's kind of rolled into this controller along with HTML, and it's all kind of in one file. It might sound crazy, but I think it's really, really great. And it's really nice to have everything, at least most of everything I need in one place. So this is where I create something called a change set. It will kind of validate the data that I'm providing. Like I said, I'm providing some initial values so I don't have to keep retyping every time I'm loading the page during development. And eventually I will replace these with empty strings or nil values or something. But anyway, I'm putting this change set onto the socket so that it can be handled by the template. And then I've also got kind of a placeholder key and value here to kind of check whether, or to store state about whether or not the user's browser supports web authentication. So that's the mount callback. That's one of the things that's required. The next thing that's required for a LiveView is a render callback. Now, you could move all of this HTML into a dedicated file, which would be kind of associated with the LiveView file under the hood. I'm not doing that yet. I do plan on separating out the HTML. I think this is probably complex enough to live in its own file, and I want to be consistent in the future anyway. So, but at the moment, this is living inside of the render function. If I had a separate file, I wouldn't need the render function if I had a separate file for the HTML here. But at any rate, what you're seeing are some components that I'm using from the Surface package or the Surface library. So there's some components built in that kind of reduce the amount of code and attributes that I need to write compared to raw Phoenix LiveView functions that I would need to, and tags and things that I would need to use. So here I pass it in the change set that was created during that mount. I've got a couple of things that are happening here. So these are attributes that tell Surface and LiveView what event needs to be fired whenever these particular events happen. So the form, whenever you are typing or changing selections within the form, it will fire these change events. So I'm just kind of saying that the app should respond to those changes. So that'll make sense in a moment, I think. And then whenever you submit the form, I actually created a different callback called challenge. We'll see that in a moment as well. This is a little bit funky here. You have to, like any custom attributes need to be put into this opt attribute here. And if you're new to Phoenix and Elixir, under the hood, this is called a keyword list. It's kind of like an object if you're coming from other languages, kind of like a map if you're used to maps in Elixir, but it's just keys, values, and so these can be as long as it needs to be. I've only got a few of these here, so I'm giving it an ID of register form. I'm turning autocomplete off. I don't want it to automatically display other email addresses that have been entered in the browser. And I'm also connecting it to something called a Phoenixhook. So this is some JavaScript. We'll take a look at that in a moment. But this is how I'm actually interacting with JavaScript in the browser to use these credential APIs. This is a component I created myself called heading. I can give it whichever level I need it to be, and basically it turns this into an H1, H2. In this case, it's going to be an H2. And then I give it some supplemental classes. There's some kind of default classes built in, but in this case, I'm kind of adding on to that, telling it that this heading needs to span all of the grid columns that I've created here using Tailwind. By the way, if you've never seen this before, these are Tailwind utilities, and I'm so happy that with Tailwind version 3, we have arbitrary values. So like there wasn't a pre-built way to define like an auto and then a 1FR. Like if I wanted to define pixels or like specify like widths for my columns or rows and things like that, I can do that with the syntax here. So I can just tell it I needed 2 columns. I wanted the first one to scale automatically based on its content, and then I want the other column to fill up the remaining space. So that works really nicely. The next thing I have here is just a paragraph, nothing special. And then the fun stuff with Surface is I can wrap, so basically I can put a field here. I can tell it which field, the name of the data that I want for this form. So it's going to look inside of the change set, it's going to look for an email key. I've got a class here just to kind of make sure it renders everything out of this. It's basically going to kind of render the contents as they are without any kind of, it's going to kind of ignore the div that this field would put in the HTML. Anyway, so I've got a label, nothing special there. You can see I don't have a for attribute because it's kind of done for me. I've got an email input, and if I look at inspect here, by the way, I can do inspect. You'll notice that, so it automatically has the for attribute because this register form email was generated for me. It does that. I don't have to keep, like I said, it's saving me keystrokes here. I don't have to keep adding attributes that are not something I need to do as a human. All right, so the next thing, hang on. All right, the next thing in this field is I've got an email input. So if you look at the HTML, it basically renders an input with the type of, where is it at? Type email. This is another Surface component. I'm giving it a custom attribute of Phoenix debounce with 500 milliseconds. And what does that mean? Well, so you remember there's a change event. So every time I type a character, if I didn't have debounce here, it would literally, immediately, every time I press a key, it would tell the server, and the server would respond. It would check my email address, validate it, and do some things. I don't want it to do that immediately. I want it to wait till I've stopped typing for at least 500 milliseconds. Of course, this is whatever you decide to make it. So I could tell it to wait a less amount of time or a longer amount of time, before it tries to validate the email. But in this case, I want it to validate after 500 milliseconds. You're not going to see anything happening here because it's kind of under the hood at the moment. I've got some classes just to kind of make this thing look nice. I will be, I think, wrapping these. I'll be building my own components to do some of the styling later. I've got an error tag here. I've got some help coming in from the Surface channel on the Elixir Slack. So definitely check that out if you ever need help. The Elixir forum and Elixir Slack are really great for getting help. I would say if you're kind of in a crunch and you need answers quickly, Elixir Slack is usually a little bit more timely. Elixir forum is great if you have something that you think people need to know, like in the future, because like Elixir forum, if you post something and you get answers on the Elixir forum, that can be found on Google. So like someone else with the same problem can find an answer. Doesn't really happen if you've only asked the same question in Slack. Anyway, that was a digression. So what's happening in these fields is the field declares the name, the label, the inputs, the error tags, all kind of are configured to look for and to set attributes based on that name within the form. Other than that, we have a submit button. Nothing really special there. It's just wrapped inside of a component as well. So most of that is, it looks like, this is the HTML that is outputted by all of that work. And then, we'll come back to the console here in just a moment. So the next thing that we'll look at is these events. So these are callbacks for LiveView. Now these are not required. Like I could disable all of these callbacks, the page would render, but then I would have problems if I tried to send events from the client back to the server on the LiveView. So I'll do a quick, let's talk about these first callbacks, and then I'll show you some JavaScript because I need to connect some dots here. So these first two functions, the nice thing about Elixir as the underlying programming language is we have something called pattern matching. So you can declare the same function name and you can give it different signatures. So in this case, I'm saying this function called handle event, if it receives these 3 arguments, then do whatever in here. And now these 3 arguments, these are actually, I don't know if you noticed, these are explicit values. So this isn't like a variable name called WebAuthn supported. This is like if this function receives the first argument as a string called WebAuthn supported, and if the second argument is literally false, and if it has a third argument, we're going to call it socket, then this function applies. Whatever's in the body will be performed. So what I'm doing right now is I'm logging that if WebAuthn is not supported, I just kind of put that in the I log that message in the server, and then I would return a message to the client in the browser. It would show up as an error message saying that this browser does not support password free accounts. I want to be consistent just because it says password free over here. So, and just another digression here. So I have way more experience in customer service than I do as an engineer. I've been developing code for at least 5 or 6 years now. I would say 3 or 4 years professionally. But if I told the user that WebAuthn isn't supported, that would mean literally nothing to the common user that I intend to use this application. So I've got to word things in a way that makes sense to most people, at least. If password-free accounts doesn't make sense, that's okay. But I think someone who doesn't understand that could reasonably turn to their neighbor, and the odds are decent that they could get some kind of explanation. So anyway, that's a digression. But like I said, there's 2 versions of this function, and I'm looking at 2 scenarios where we receive WebAuthn supported. If it's false, we tell the user there's an error and you can't really sign up for this app, or at least using that browser. Now, if WebAuthn is supported, so we get this true value, the user doesn't really need to know anything because it's just going to work, right? So I don't really do anything. What I do is I just return the socket unchanged. And I do that because it's required. So before we look at these other functions, I'm going to jump into, let's connect some dots here. So a minute ago, I pointed to this thing called a Phoenixhook, and this is the name of the Phoenixhook, handle WebAuthn. So I don't know if you noticed here, but I've got a JavaScript file. By the way, these other files are not super important right now. So this is where I've created something called a Phoenixhook, or I think to be more specific, this is a kind of like a LiveView hook. There's a different type of hook called a session hook. So since this one interacts with JavaScript, I like to call it a JavaScript hook. So this is the one I was just pointing to called handle WebAuthn. This actually gets sent back to the main app.js file. But what happens is, as soon as this is mounted, it's going to log a message into the console. So as long as you're using this in a browser where WebAuthn is supported and enabled, the first thing that'll happen in the console is you'll see a message that says WebAuthn mounted, and then you'll see WebAuthn is supported. And that happens here. I'm sorry, I'm jumping around a little bit, but if the browser does have an object called navigator. If it in the navigator object, if it has a credentials key, that's an indicator that this is supported. So I tell the browser that. I also tell the server that. So if credentials was not in the navigator, then I would put an error down here. I would tell the server that it's not supported, and then the server would render that error message to the user. Now that might sound a little bit verbose. You know, you might be asking, why am I sending that back to the server? I could just render a message directly. You know, this is already in JavaScript, so it's already in the client. Why am I telling the server that it's not supported? Well, you know, think about this. If in, let's say, 3 or 4 months, if I've got users connecting to this app across the world, and I have, say, 30% of my users who are hitting this kind of hurdle or like a brick wall where they just can't register because their browser doesn't support WebAuthn, then that would cause me to kind of rethink what I'm doing here. It would be really good to know that. I would really hate for that to be happening and then not know about it, and then have people complaining on the internet, or, you know, getting angry that that there's this error that no one knows about. So that's why for this particular feature, you know, I do want the server to be aware so that it can keep track of how many users are hitting that error, and then I could reevaluate my idea about this passwordless situation. So we'll come back to the case where WebAuthn is supported in just a moment. Regardless of whether it's supported, we're going to add a couple of event listeners here because these are kind of semi-unrelated. Actually, like this one probably should be moved into the case where the credentials are supported. You know what? Let's do that now. This would make more sense anyway. Okay, you know what? Just knowing what I know, like these event listeners would never be triggered if WebAuthn was not supported, right? So, okay, so this makes a little bit more sense now, and we can go in order. So, if WebAuthn is supported, we tell that to the server, and then we set up these event listeners. So the server is going to do a few things as the user starts to fill out the form and as I hit submit. So the server is going to send these messages across the WebSocket to the browser. And if, by the way, if this doesn't make sense now, it's okay. I think if you start to learn about LiveView, it just takes a little bit of time to kind of understand, you know, especially with WebSockets, it's kind of a new thing for most developers. So if this sounds like gibberish, it's okay. Maybe rewatch the video a few times. I've definitely done that with stuff like this in the past. Anyway, so eventually, once the user has filled out an email and username, assuming those are not already claimed in the database, then the server, whenever they hit submit, the server is going to say, hey, I've got a challenge. It's going to send some data to the browser, and then the browser is going to handle that. So let's jump back to, I'm going to save this file before I forget, and then let's look at the server again. So this is the LiveView file. Let's see, we've got that change. We're going to ignore that. We've got the challenge here. So whenever the server receives a challenge message, so this is what happens when you hit the submit on the form. You know what, it occurs to me, I'm just going to call this submit because I think challenge on this app, it's just going to make it more confusing. So we're going to say anytime there's a submit from the form, we're going to handle it this way. So what happens here is I'm listening for, remember that first argument, anytime it comes through as submit as a string. The second argument is actually a map of keys and values. So I'm kind of destructuring all of that data inside of the function signature. What's really nice here is this pattern, this function will not be called if there's no map structured like this inside. Now the map could have extra keys that I'm ignoring, but the ones that I really care about are listed here. I can assign this kind of inner map to a variable called user. And then the third argument for this function is called socket. So again, by the way, this second argument is actually a map with multiple values inside of it. That's probably confusing if this is the first time looking at Elixir, but trust me, it will start making sense, especially if you start writing code like this. All right, so what I do from there is I take the user, I'm putting it into, I'm kind of just reassigning the keys as atom keys. I probably don't want to get into explaining atoms versus strings and maps, but just trust me, these are atom keys for now. And then I'm doing a couple things here. I need to create a challenge that the server will send to the browser. This is the first step in creating a public key. So I'm using a library called wax. If you're looking at hexpm or hexdocs, make sure you search for wax underscore. There was a naming conflict or something. So what it does is it creates a registration challenge. I've got a couple of things hard-coded here. I'm discouraging user verification, and attestation is none. Those are things that I don't expect to ever change. So as much as I hate to hard code any data in apps, there are times where there are exceptions, right? So aside from that, I have origin. So actually this is going to be a dynamic value. Right now I'm running this locally on my laptop, so it's going to be localhost. But in production, this would be an actual URL. And the browser needs to know that actual URL. So this will allow me to dynamically, set the origin based on, where the app is running. And then RPID, this is something called the relying party ID. The WebAuthn guide and the WebAuthn IO and all the documentation will explain relying party better than I can. But this auto is just telling you that I don't really need to customize it here. It's just going to, like this wax library is going to figure out what to do. It's basically going to put a live localhost here. Whenever I deploy to production, it's going to put whatever that URL would be here as well. Probably over-explaining things a little bit here, but anyway, what I do at that point, I've got a challenge that needs to be saved because later on I will need to get that challenge and check it against what the browser sends back. So the nice thing about LiveView is this whole page, like this file that I've created, all these functions, inside of Elixir, this runs as a process with its own memory. And with Elixir and even Erlang, which kind of precedes it, these processes have their own garbage collection. So everything runs nice and concurrently and even in parallel. And I can put some data inside of this process, and it's only there as long as the process is alive. Whenever the process dies, the scheduler in the background will go through and clean up memory that's no longer referenced by any processes. So it's really, really clean. I don't have to deal with memory management on my own, at least for the things I'm doing. And it's really, really beautiful and fun to develop in. So anyway, like I said, I'm putting a challenge here in the process memory so I can fetch it later. And this, so this is only going to be retrieved inside of my process. And then I'm sending some information back to the socket. I'm telling it there's a new event called challenge. And then I'm sending all this data across the wire on the WebSocket. So I'm giving it an app name. This one's hard-coded. A couple more hard-coded pieces of data, but it's encoding some data. And it's grabbing some things out of the challenge that I created a moment ago up here. And so this is what the browser is getting inside the JavaScript. It destructures this out of this data.detail object, and then these are the values that I'm grabbing out of that. So a lot of these things come across as uint arrays and array buffers. This is something I had to learn about while I was building this because I kind of crossed paths with array buffers before when I was kind of learning JavaScript, but kind of put off learning about this. In a nutshell, an array buffer is different from an array in that it doesn't actually contain the values itself. An array buffer is just kind of like a reservation of some memory of a fixed size. And I may be getting this wrong, but that allows you to do some really cool things where you have like kind of direct access to memory in that array buffer. through JavaScript. But that's what's used for this credentials API. So in a nutshell, if you want to learn some actual truth about array buffers, definitely there will be better resources online for that. But what I do here is that it kind of, what does it do? It kind of decodes, there's a base64 encoded string, so it kind of takes that and splits it and then converts it to character codes. Then the next thing is I'm creating a public key. So this is basically an object that is passed to the credentials create function. And so this is all documented on the MDN and the WebAuthn guide. But these are all the things that I've set up on the server. A couple of these are hard-coded because these just won't change. This is the, at least not rapidly. So timeout, key, cred params are not going to change anytime soon. But these other things are being configured by the browser. I'm setting up a random ID because the browser doesn't really need to know about the user's actual ID in the database, and it doesn't really exist yet either. So this is kind of a placeholder. It's not really important for the lifespan of the app. But yeah, that's where we're putting the email and the username for the user. That'll be kind of associated with the key in the browser. So all of that configuration is passed to this function. This actually returns a promise. So I don't know if you noticed, I created this as an async function because I'm handling a promise here, and async await is kind of the cleanest way to respond to promises like this. So I get I'm destructuring this data immediately when it's available from this promise. And then I'm further destructuring the response. So this raw ID will actually be sent back to the server and encoded in the browser. and then decoded in the server and stored in the database. This response has to go through, we have to jump through some hoops before we can send this back to the server. So just, we're going to be a little bit hand wavy here, just doing some things so that the server can understand what was done on the client. Quick pro tip here. With JavaScript objects starting in around 2015, 2016, and with modern browsers, there's a shorthand for objects. So if you wanted to set a key and a value for, like, say, attestation 64, you can do this, or you can omit the colon and the value, and this will accomplish the same thing. So you'll notice here I don't have key values for each of these. JavaScript will actually, it's kind of like shorthand for like using a key value that have the same, like this is a variable that's being assigned as a key with the value from the variable. Okay, so I hope that made sense. That's the challenge being returned from the server to the browser. The browser is taking that challenge, creating a credential, and then sending the credential up to the server. And this works, I would say, 99% of the time. There are some edge cases where I think I may be mishandling something. I get errors every once in a while, but I haven't seen one of those in a while. So let's just say it works for now. The next thing we'll look at is what happens when that credential is sent back to the server. So we just saw the JavaScript side of this. These are the items that were sent from the server except for the type. Am I sending the type? The type is being sent here, so I should just take. Oh, you know what I'm doing here is I'm making sure that this function only runs if the type from the client is actually called public key. Otherwise, this whole function just won't, there will be an error. So that's a good thing. That's what I want the application to do. I'm also grabbing the change set because I need to take all of that user email and username data, and I need to put that into the database at this point because it hasn't been placed in the database before. So here's what happens. I take the user out of the changes of the change set. Definitely look into the documentation for ecto change sets if you haven't, if this doesn't make sense. I've got to do some decoding, a little bit more hoops I need to jump through to process the information. This is where I get that challenge that I put in the process memory just in that previous function. And then I've got a little bit of logic here. This could probably be cleaner, but I've got a nested case statement here. Basically, I use this wax register function, and this takes the data that I've parsed from the client, and as long as it is successful, it will say okay, and I'll get some data back. So I take this data, I jump through some more hoops, I register the user and the key, and so those are actually processed as an ecto multi. So let's just do a quick look at what that is. So register user with key. This is what happens here. We get the user attributes and we get the key attributes. And this function is kind of actually calling some other create functions in this module, but it wraps them inside of a database transaction because, I'm pretty confident that the user is going to be created successfully at this point because I've already done validation. I'm also fairly confident that the user key is going to be created. I do need to fetch the user ID so that can be associated with the user key. But if anything goes wrong here, I need all of that inserted data to be removed from the database. So we kind of need to say oopsie doopsie and then remove it from the database and do a clean start. So that's the benefit of doing a transaction. Like I don't want to be in a place where I have a user, but I don't have a user key because that would lead to problems. So that's what happens whenever I tell the database to store the user and the key. As long as that is successful, I will get another OK message. I'll get some data that I can use here. I don't really need to use the user key at this point. I will generate a token. So that's generated from Phoenix as well through this application. I do some encoding and then I send that token to the server. And this token is really nice because instead of storing like the username or the user ID in the browser's memory, like I'm putting this in session storage. I could use local storage if I wanted to, but that would potentially be a security issue because then if another, say an extension is able to access it, or I've got a security vulnerability and say another site is able to access, you just can't ever be entirely sure that the memory within session storage or local storage, it's not entirely secure. So that's the reason I'm using a token. The token is only, what is a token? Let's look in the database because I think that'll help clarify what it is. So whenever this function is called, it puts the user in the database and it puts a user token here. So for this user, Owen at fake.com, we have a binary token. In the browser, this is what it looks like. Actually, it's already been cleared. But it'll be base 64 encoded, so it'll look like a string of random numbers and letters. And that way, whenever the user navigates to different parts of the app, it will remember that they've already logged in, so they don't have to keep logging in every time they hit a new page. And there's no user data stored there. It's just it's like a key in the database that can expire. And that key is invalidated. The browser will remove it actually whenever the user clears out all the tabs for LiveShowy. If I'm using session storage. Now, if I used local storage, that token could stick around longer, until they clear their cache and cookies, at least for the site. And that might be useful. That might be something I do later. The token would still be secure because it would expire. It's only good for a certain amount of time, and it's only good for that user, and it's only good if the user is trying to use that token from the URL that it was created on. So there's like an origin that it has to be associated with. So that's the beauty of Phoenix tokens. We could probably spend more time on that, but I think you get the gist. What it does is it puts the token in the session, renders success. In the future, it's going to redirect to a settings page. But that's a work in progress. If there's an error, it's going to render an error here. There's a couple of different errors that might happen. So we'll just kind of ignore those for now. What else do we want to look at? Okay, so the last thing that I'll point out here is there's a couple of checks that I have. Let's say that you have logged into this app. You've been a user already. And I don't know, maybe you hit register by accident, or you handed your device to someone else and they want to register, well, you don't want to have your user token saved because that session should be kind of invalidated. Like once someone registers, they're going to be registered as a new user with a new token. Your user will still be in the database, but we need to clear that token at least in the browser. So that's what we do. If you hit this registration page and the browser says, "Hey, I have a user token," if it comes back with null, the server will kind of ignore that and just not do anything. But if it comes back with a token that's actually rendered as a string, it's going to decode the token, and then it's going to also check to see if that is a valid token. And then it's going to tell the browser to clear that token. Otherwise, it's just not going to do anything. Now, I could probably skip the step here and just tell the browser to clear the token regardless, because I think it would make sense to do that. But I want to think through that a little bit more before I update that code. So I think that covers everything I wanted to show you about LiveShowy so far. One thing it just kind of crossed my mind here. I have a landing page for this app. It's very basic. It's very primitive. There's not really much to it right now. It's liveshowy.com. The reason I wanted to pause on this for a moment is the URL. Maybe it's a problem. Maybe it's not. But the URL, the reason I called this app LiveShowy is because this URL was available. If you go to liveshow.com, that's live show without the Y, you're going to hit a porn site. And, depending on your preference and your situation, maybe that's not something you want to do. So just on the off chance that you're curious about this and you want to learn more, make sure you go to liveshowy.com. You can also check out, I've set up a Twitter account. It's semi-active now, but you can go to LiveShowy app. And so LiveShowy app is the account for this. You'll see some of the work I've been doing here. I like to post what I'm working on sometimes. I've got a snippet here from Big Elixir. As soon as we get a video from Big Elixir, I'll be posting that here as well, so you can see how the first demo went. It was a really, really fun thing. And so I look forward to live streaming more and sharing more about what I'm doing with LiveShowy. And if you are an Elixir Phoenix developer or even a JavaScript developer, I think we might have some fun stuff to talk about. Also looking forward to, so this is a music collaboration app. I don't know if I said that really clearly before, but the whole idea is people will be using this app to play music with each other in real time across the internet. Something that's really hard to do right now, but I have some ideas of how to make that fun and enjoyable and reliable. So that's what I'm working on. Thank you so much for watching my live stream. Next time, maybe my webcam will be working and you'll actually see me. Anyway, I will catch you next time. Thank you.